Okay, so chapter 1, section 6 is classifying polygons. A polygon is just a type of shape, but it has very certain criteria. Not every shape in the world is a polygon. But once we identify what things are polygons, there are some rules that apply to them and some things that we can do. And you've actually dealt with many polygons already. You'll be like, oh, okay, yeah, I've done that before. So the word polygon means many angles. It is a closed plane figure formed by coplanar segments called sides. So closed plane figure, what that means is like it can't be open. And what I mean is like this. I'm going to draw one that is not closed plane. I'm going to draw something that looks like a triangle, but I'm not going to close it at the top. Notice that it's got a gap at the top. That's intentional. That is not a closed plane figure. This is going to be like a fence. Whatever shape I draw has to be like a fence that it fences in whatever it is. It has to be closed off. Like all the ends touch each other so that it's closed. That's what we mean by that. It's a closed plane figure formed by coplanar segments called the sides. Each side must intersect exactly two sides, one at each endpoint. So whatever side you choose, notice that, like I'm looking at this left-hand side here. Each side intersects exactly two sides. If you notice, the one that I just colored intersects the top and the bottom, and they meet at their endpoints. They don't meet in the middle, they meet end to end. Like this would not be a polygon because it is not end to end. You see there's that overlap up there? Not a polygon. So that would not be one. It has to be end to end. No two sides with a common endpoint are collinear. So we can't have a side that looks like this. That would not be two sides right there. Notice that's like a straight line there with just a point in between. It says no two sides with a common endpoint are collinear. That would not, like, I can't make, like, I couldn't call this a rectangle. Clearly, you'd be like, but that's a triangle. Well, not if it's got four sides, it doesn't. And those are not sides at the bottom. You see a side on the left, a side on the right. That's not two sides at the bottom. That's one side. It just has a point in between. So just to be clear, those just because there's a point on there doesn't make it... Wow, that was a late bell. It does not make it two sides down there. Each endpoint of a side is a vertex of the polygon. So when we're talking about these polygons, whether it be a triangle or a square or a rectangle, all those points where the sides meet are called a vertex. Now, the plural of vertex is vertices. So you're going to hear me say vertices a lot. That is the plural form of more than one vertex. There is like all of the vertices of a triangle. Means all the different vertex. One vertex, two vertex, three vertex. Those are all the vertices of a shape. So some things it's got to have. It's got to be straight lines. Number one, all of these, whatever a polygon is, it's made of straight lines. They're always straight. They go end to end. There's no overlap, nothing sticking out randomly. It's got to be closed. And all of those little points there are all called vertex. So what the other thing that we shouldn't see in any polygon is we should never see lines cross over each other. For example, I could draw a rectangle. Or here, let me draw a better shape. This is a shape that is made out of straight lines. That is not a polygon. Whenever we see lines that cross over each other, we can expect that it's not a polygon because of a couple things. Right there, that every endpoint should only connect to two other sides, but sometimes they connect to more if we have those weird shapes. So anytime you see lines crossing over other lines, it's a good sign that that is not a polygon. So we're going to look at some examples here in just a second. So we're going to look at ones that are polygons here and ones that are not polygons. So let's talk about A. Based on what we just said, is A a polygon? Yes, it's closed. It's made of all straight lines that go end to end. Nothing is crossing over each other. It meets that criteria. Now we're going to talk about what we would call that shape in a minute. What about B?
No.
Why not B?
Because they don't connect like everything.
What do you mean they don't connect?
Like,
So right here, we're missing that piece that would make it a polygon. It's an open figure. I always think of it like a fence. If this were a fence around your house, could people get in and out? If so, then that is not a closed plane figure. Now, unfortunately, I gave C away. We know that C is not a polygon because we've got all these points in the middle of lines there, right there, and they're crossing over each other. So when we see that crossing over there, that's not going to be a polygon. What about D?
Yeah.
D meets the criteria. It's made of all straight lines that go end to end. It's closed, all those things that we are looking for there. So how about E? Why not E? It's not closed. That's not going to keep anything in there. Like, it is not going end to end. Notice that here, they're all meeting up, and one line is meeting up with two lines, which really, like, that would be okay, but not at the same point. They shouldn't all be meeting up here. They're convergent, and that's not okay. So we're going to talk about the difference between concave polygons and convex polygons. And hopefully you've heard these words concave and convex before, even if you're not sure what they mean. And a lot of times I hear people talk about concave, like concave is like a cave that it goes inward. There's part of it that looks like it's been like kicked in. Like a cave is actually concave because there's part of it that goes inward. Like you could go inside the cave. Whereas a convex has no part that's going in. But we're going to get more technical in geometry and says no line that contains a side of the polygon contains a point in the interior of the polygon. Here's what I mean. Pick any point on this polygon to decide whether it's concave or convex. And I want you to go to either of the two vertices that are right next to it. This one and this one. Notice that by connecting these dots, I am not going inside the shape, correct? I'm not crossing through the inside. Like all I'm doing is following the edge there. It doesn't matter where I do this, I will never cross across the inside. We're going to see in a moment that there are some shapes that if I were to cross over, so it's that they would go through the interior. So it says no line that contains a side of the polygon contains a point in the interior. So again, all of these lines, I like to look at like this. The easy way is this. If I were to take these lines and extend them, let's say that they were lines that kept going forever. No matter which line I do, they will never extend through the interior, even if I keep extending them forever and ever. Watch as I continue these. Oops, sorry, that one I drew poorly. This line does not cross through the interior. This one here does not cross through the interior. This one here does not cross through the interior. It's a great way to tell. If it doesn't go inside, it's not concave. This one is the convex. Same here. Doesn't go through the interior. Doesn't go through the interior. Doesn't go through the interior. So all these examples are convex polygons because if I extend these lines, they would not go into the interior. And I believe the next slide is going to show us ones that we've got concave. So a concave polygon, we're not going to see that same thing. We're going to extend those lines and we're going to see, watch this one here. Does not go through the interior. Okay, well this looks convex. Does not go through the interior. Okay, convex. Does not go through the interior. Still convex. Does not go through the interior. Okay, well this is starting to look convex to me until I get here. Notice here that when I extend that line, it cut through the middle of the shape. That is a guarantee that this is a concave shape. But actually, I'm not going to lie to you. I don't ever do that now that I've done this like so many times. I don't ever look at that when I do it. That's the technical version. What I look at is, does this shape look like it has part of it that's been kicked in? And to me, I would say, yeah, it looks like that upper right, somebody shoved it or dented it inward. And that's how I tell something is concave, by looking at that. But the truth is, if you're not sure, just extend all the lines and if they cross through the middle. Notice here, I look at that upper right-hand corner, it looks like it's been dented in, but if you're not sure, okay, well, not this line, not this line, not this line, not this line, but this one definitely goes through the middle, and so does this one right here. It goes through the interior of the shape. That's how we identify a concave polygon. I always think of if you're stuck between the two, think of the word cave like a cave goes inward. If I were going to go to a cave inside a mountain, it goes inside the mountain. It's like a tunnel in there. It's punched in, it's dented in, however you want to say it there. All right, so here, These are all the names of the polygons that we are going to have to know in this class. Understand that there are polygons that have, these are not all of them in the world. There are numerous amounts of them, but we're going to focus on these here. Now, here's the ones that I know you are familiar with. I have no doubt. A three-sided polygon is called a triangle. I have no doubt that you know that. It's three straight lines going end to end. You've seen triangles plenty of times. And I'm sure that you probably know that an eight-sided figure is an octagon, because that's like a stop sign. It's an eight-sided figure. It's called an octagon. Now, hopefully you remember from elementary school that a six-sided figure is a hexagon, and a five-sided figure is a pentagon. And from there, we start to get to some things. Then people go, why do I not call a four-sided figure a square or a rectangle? Because squares and rectangles are both different things, right? A rectangle does not have to have four congruent sides or four equal sides, where a rectangle needs to have two that match each other left and right, two that match each other top and bottom. So we call all of those four-sided figures quadrilaterals. The word lateral means sides. When you see that, I'm going to say lateral a lot. If you are somebody who goes to the gym, when you work your lats, really what you're working is if you take your fingers from your armpits and run them down your side, you're really working that area, those muscles right there. I mean, clearly I'm pretty swole, so like that's where I work. I'm just kidding. So when you hear that area, lateral just means sides. So quadrilateral means a four-sided figure. So be careful, because a lot of people, when I talk about a four-sided figure, they will call it a square and they will call it a rectangle. Both squares and rectangles are a kind of quadrilateral, but quadrilateral is a general name for it. For example, I could say everybody in here is a human. I could get more specific than that, and we could break each other up into groups based on gender, based on age, based on lots of different things. We can get into smaller subgroups all we want, but right now we're just talking about a general name for four-sided figures. That's quadrilateral. Now we start getting into the other ones that a lot of times people may or may not. Decagon is one that a lot of people might know. The word, like a decade, is 10 years. You see that deca at the beginning there, like a decade. So that's a 10-sided figure. A nonagon is a 9-sided figure. Now I will tell you now, you are responsible for knowing the names of these, not just for the test from now on. Like I'm going to refer to a heptagon or an octagon or a hexagon, and you should immediately be pulling into your brain, how many sides does that have? A heptagon is sometimes referred to as a septagon. So these two names mean the exact same thing. So if you see it somewhere else listed as like some material calls it a septagon, some material calls it a heptagon, they are the exact same thing. There's no difference, just two separate names. Why do they have two names? To be honest, I don't know. I actually never have cared enough to like sit there and go, I just go, that the two names are the same thing. And a dodecagon, I always make myself a little trick. It's like a dodecagon. It's a 10 with a 2 like on it. So it's a 12-sided figure. Last but not least, you're going to see an n-gon in there. Above 12, I don't really care about you knowing the names. Understand that no matter, n is a variable there. It just means whatever number we're talking about. So if I'm talking about a 34-sided figure, I would call it a 34-gon. So above 12, you're going to see me do a lot of these like a 20-gon. What that means is just a 20-sided figure, because I'm only asking you to get these, a 3 through 12. Notice that we do not do an 11 in there. That's because an 11-sided figure is a very awkward figure that we'll get into a little bit later. It's just not one of the normal figures. Kind of a weird number to work with. But the others come up very often. So this is a very important one that find the ones. I'm not saying sit there and memorize every single one. You know some of these. Pick out the ones that you don't know, and those are the ones that you're going to be like, which ones do I need to know? Which ones do I need to work on? Yes, sir.
So n can be any number above 12.
Yep. So let's say I've got a 100-sided figure. I would call that a 100-gon. And a million-sided figure, a million-gon. All right. So now we start getting into equilateral, equal angular, and regular polygons. So there's 3 words, and they all sound a little bit similar in the beginning. They don't, like 2 of them sound similar. So what did we say this word lateral means? What is that referring to? Sides. So the sides. So what do you think equilateral means? Like, just if you had to guess, what do you think it means?
Equal sides.
All the sides are equal. So a square is an equilateral figure. It's got all the sides that are equal. A rectangle could be like it could be, but not all rectangles are equilateral. Some triangles are equilateral, some are not. The word equilateral just means all the sides are the same. Equiangular, guess what's all the same when we say equiangular? All the angles are congruent. So every single angle on the inside of there is the same. For example, here's how I would show an equilateral triangle. Here's equilateral. This is a triangle, and I could show it by doing this. 1, 2, 3. Notice I did the congruency tick marks on there. That shows that the sides of this triangle, whatever they are all equal. So if I put a 6 here, I know that they're all 6s on each side of this triangle. That is an equilateral triangle. Whereas an equiangular triangle would look like this. Instead of doing the tick marks on the sides, I'm going to do those little angle marks that we showed, showing that all 3 of those angles are the same. Whatever those angles are, all 3 of them are the same. If you're falling asleep on me, find a way to wake back up, because this is where the stuff that you're going to be tested on is coming. So, equilateral means all the sides are congruent. Equiangular means all the angles are congruent. So we have this word regular. Regular is not like, doesn't mean like, oh yeah, it's just like a regular old square, like a boring old square, or a regular old triangle. It actually has a very specific definition that means all the sides are congruent and all the angles are congruent. So a regular triangle would look like this. A regular triangle has both things. It has the sides are all congruent and the angles are congruent. A regular quadrilateral, a quadrilateral is a 4-sided figure, remember, would look like this. All the sides are congruent, all the angles are congruent. I use boxes in this one because I happen to know that in a square, those are 90-degree corners. I know that. But you could use the round ones in there too, and that would be fine. A pentagon. Equilateral, equiangular means that that's a regular pentagon. So when you hear that word regular, it means something. It means all the sides are congruent, all of the angles are congruent. It's a very important word right there. People forget about it all the time. Like they just kind of write it off like it's not important. All right. So tell whether the figure is a polygon and whether it's convex or concave. Okay. So let's decide. We're only going to say whether they are convex or concave if they are a polygon. So let's first decide whether this is a polygon. Yes, sir.
It's not.
Why not?
Because it's cutting through the middle.
Because we've got this piece right here going through it. That's the dead thing right there. Without that piece, my answer would be yes, that it is a polygon, but it is not a polygon. Because remember, there should only be 2 sides that meet end to end. And look how many we have meeting right here. We've got 1, 2, and 3 sides meeting up. That's too many sides meeting up. We should only have 2 sides meeting up in any one vertex. There are 3 sides meeting up at this vertex. Nope, not a polygon. So I don't need to worry about whether it's concave or convex. Is this a polygon? Yes, it's closed, made of all straight lines, even if they're a little jagged looking there. So it is a polygon. Let's be more specific here. Let's call it by its name. This has 1, 2, 3, 4, 5, 6 sides. What kind of polygon is it? It's a hexagon. And is it a concave or a convex hexagon? It's convex. And if you're not sure, notice that any of these lines, if I were to extend them, would not go through this hexagon here. It would not go through the interior. So this is definitely convex.
Wait, I have a question.
Yes, sir.
So then if that's the case, wouldn't A be concave?
So remember, it would, except for we're only naming the polygons. We're only naming, in this, we said this is not a polygon.
Wait, Wait, doesn't concave mean it cuts to the middle?
Right, but we're only going to refer, you are correct in everything you're saying, except for the only thing is we're only going to name something as concave or convex if it is a polygon. This isn't a polygon, so we're not even going to try to determine what it is. All right, how about C? Is C a polygon?
No.
Why not?
It's not a straight line.
Not a straight line, and that immediately eliminates it right there. A curved line, not a polygon. So nope, we're not even going to consider it as whether it's concave or convex, because right now that's all we're considering. All right, polygon?
Yes.
Yes, straight lines, they all go end to end, no overlap, no crossing through. Now when we name this, be very careful. So watch, I'm going to number the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the name of this polygon? A dodecagon. These are the kind of things that you might be asked on a test. What is the name of this shape? It is a dodecagon. And is it concave or convex?
Concave.
Okay, so, I heard both. Concave or convex?
Concave.
Definitely concave, because watch what I can do right here. It crosses through. As soon as I make any single line, if there's any single line up there, even if it's only one that goes through the interior, then this is definitely going to be concave. And look how many lines I have that are going into the interior there. Got a lot. So this is definitely concave. All right, so it says classify it. When the word classify just means to name it. That's all we want. Name it by its number of sides. Tell whether the polygon is equilateral, that all the sides are the same, equiangular, all the angles are the same, or regular. And remember, regular means that both all the angles are the same and all the sides are the same. That means all of them. Every single side has to be the same as every other single side. Every single angle has to be the same as every other single angle. So again, let's start by naming this. How are we going to name this polygon? 6 sides, so this is a hexagon. Is it equilateral, equiangular, or is it regular? Regular. So here's the part that is equilateral. It's definitely equilateral. Here's the part that is equiangular. If you notice, every single angle is the same as every other single angle. It only has one line, so that I know that all the angles are the same. If it's equiangular and if it's equilateral, then it is definitely a regular hexagon. So we'd call this a regular hexagon. Right away, when somebody tells you it's a regular hexagon, you can automatically draw that in. And what I mean is this. Let's say I give you a problem that says there's a regular hexagon, then you know you can immediately do this right from the beginning. You can go, oh, well, that's congruent, that's congruent, that's congruent, 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 congruent. This angle matches that angle, matches this angle, matches that angle, matches this angle, matches that angle, just from the 2 words regular hexagon. That's what that means. Let's name this second shape. A quadrilateral. It is just a 4-sided figure. And let's talk about, is it equilateral, equiangular, regular? None of the above. Why not? Good. Now here's the thing. This is made to trick you because this is the same as this. But this one is the same as this one over here. Not all 4 sides are the same. Definitely not equilateral, which already knocked regular off the table there. If you're not one of the things, you definitely can't be both of the things. And if you notice, these 2 angles are the same, and these 2 angles are the same. So all 4 angles don't match each other. Just those opposite pairs there match each other, which means it's not equiangular either. It's none of those. It's not equilateral, it's not equiangular, it's not regular. It's just, there's some information about the angles. We don't have a name for that. It's just, there's one set of congruent angles, there's another set of congruent angles, here's one set of congruent sides, and another set of congruent sides. That's all we've got there. No name for that. How about this one? What are we going to call this one? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Dodecagon. Is it equilateral, equiangular, or regular? Yep, so we've got equiangular, we've got equilateral. All right, last but not least, and then we are done for the day. A table is shaped like a, now watch what I'm doing, and you need to be able to pick this word out too, is shaped like a regular hexagon. In any other context, I would say regular is not that important of a word. It's just kind of like a boring old version, but this means something. It means all the sides are the same, all the angles are the same. I don't even care what the rest of this problem is going to say. Here's what I'm going to do because of that. Here's what I know. As soon as they said regular hexagon, I don't care what this problem is going to say. I just want to know that all of these things are congruent. That's a key piece of information I'm going to mark right away. A table is shaped like a regular hexagon. The expression shown represents side lengths of the hexagonal table. Find the length of a side. So let's put that information to use. If we want to know the length of a side, how can we apply that information in hopes of finding something out? If I wanted to know the length of a side, what would I need to know? Like what piece of information is missing just by looking at there? What is the key thing that I need to be able to solve this? Sir?
X.
X. I need X. So how are we going to find X? Yes, sir.
3x plus 6 is equal to 4x minus 2.
Good. Notice that we said that this is congruent to that. We said they're equal. That's what those tick marks mean right there and there. When we said regular, we said those sides are the same. So 4x minus 2 is equal to 3x plus 6. It doesn't matter which one's on the left and which one's on the right. Add 2. Add 2. 4x is equal to 3x plus 8. Notice me writing my steps out because these are the steps I would expect to see in your homework if you are planning on getting full credit. Subtract 3x. Subtract 3x. X is equal to 8. Let's pretend I said x is equal to 8, and I say, there's my final answer. I'm done. What did I do wrong? Yes, sir.
You didn't plug it in.
I didn't plug it in, and I'm showing that because it's a very common mistake to stop there. So I'm going to plug it in. I don't care which one you plug it into. You plug it into whichever one you want. That will be easier for you because you know that these two things are congruent. Now me, I'm actually going to plug it into the 4x minus 2. I know we kind of avoid subtraction, but 4 times 8 is 32, and 32 minus 2, that's easy. That's 30. But let's say that I plugged this in up here and I've got something different. What does that tell me about my number? What about my x? It's wrong. You have the wrong x. If you plug it in, and it either means you did your math wrong on the left or you did your math wrong on the right, these things have to be equal. Watch. 3 times 8 is 24, plus 6 more is 30. They are definitely equal to each other. That's what we're looking for there. That is a 30-inch side. Notice I wrote the units there. I am definitely going to be looking to make sure that you put the units on there. It's 30 inches. Questions on that one?
The unit of,
All right, I'll leave that up.